I've been watching a lot of videos about the Big Bang Theory, and there's some interesting things in there, and I'm going to explain to you what I discovered. And these are going to be interesting things that maybe the average person doesn't know. So we don't know what happened before the Big Bang. It's possible, if you consider our universe to be the Big Bang, it's possible that this could have happened in infinite times before we existed. And it's possible that there could be other universes outside of ours that are going through their own Big Bangs, etc. And there's people who believe that the Big Bang may have caused from a collision, two objects colliding. So some interesting facts. Everything in our universe used to be in a small object. And I don't know how small they say it was, if it's a baseball or a golf ball, but it was a very small object that contained everything that's in our universe. That means that all of the atoms were squashed down into something that small, smaller than a black hole. And then it exploded and it expanded rapidly. I think it was 5 billion years ago, or maybe it was 2.5 billion years ago. I don't remember for sure. 5 billion maybe. So one of the things that's interesting is we've got all these galaxies. We live in the Milky Way galaxy. You've heard of the Andromeda galaxy. And there could be an infinite, well, obviously it can't be infinite, but there are millions and millions and millions, if not more, galaxies out there. This wasn't known until the 1950s. In the 1950s, people thought that there was only the Milky Way galaxy. They had no idea that all those millions of galaxies were out there. Another thing about the Big Bang Theory, well, about watching, is that you've got black holes. And a black hole is basically at the center of your galaxy, like the Milky Way. And things light cannot escape it. It sucks stuff in. But at the same time, I believe that the creation of stars occurs where the black hole is, but I'm not sure. And what happens is every day there are large numbers of stars being created. I don't know if it's tens of thousands, hundreds of thousands, but there's stars constantly being created, and I think they're coming out of black holes. So another thing that I learned is that they were talking about the human body. You have a certain number of atoms in your body, and they say that there are more atoms in your body than there are stars in the universe, which was quite interesting. There's something called a free planet. I don't know if it's called a free planet, but there are planets that are not in solar systems. So if you go out in outer space, there will be a planet that's just floating around, which is interesting. There's a belief, I think, that we're at the halfway point in our evolution. If you want to use evolution, I guess I shouldn't say evolution. We're at the halfway point in our existence. Over the course of billions of years, we're at the halfway point until the universe either collapses on itself or when the sun expands to the point where it engulfs the earth, etc. Part of what I read is going to be quantum mechanics. So it's believed that Einstein was wrong about quantum mechanics. And then there were these other guys, Neil Bohr might have been the names. Bohr was one guy, and maybe the other guy's name was Neil. So they believed in spooky mechanics where you've got two particles that are related. And they can be distant from each other. And if you affect one, it affects the other. And there's an experiment that somebody did where he took these two particles and he separated them. I guess it was 21 miles apart, and it was done on some islands. And he showed that when he measured one, it somehow affected the other, or if he did something to one, it affected the other. So there was a guy named Bell who came up with a formula, and he says, well, this is the formula you're going to use to prove if Einstein was right or if Bohr was right. And Einstein's theory was if you have two boxes, one with a left-handed glove and one with a right-handed glove, and you open both of them, the state was predetermined. And Bohr says, no, they're not. What happens is if you open one, when you observe it, the other one immediately becomes the opposite, which is nearly impossible to prove. How do you prove what the other one was before you looked at it? But apparently, so people did experiments on Bell's theory, and they proved that Bohr was right and Einstein was wrong. And I don't understand why. I understand how the experiments were done, but I don't understand the formula. And this was done a long time ago, like the 1950s, 1960s, by some college kid, and it's been verified many times over. So it's generally accepted that two particles in quantum mechanics that are far apart, if you affect one, it affects the other, and the state cannot be known, and if you measure one, the other one becomes the opposite, and not that it already was the opposite. It's really weird stuff. So now quantum computers have the computing part is actually really small. You know, it's like a little computer chip, but the actual computer is huge. They're very large devices, and they exist, and they're being produced. They're being manufactured. D-Wave might be the name of a company that makes quantum computers, and they're used by companies like Google and Boeing, etc. And if you understand regular computers, they're based on bits, 0 and 1, true and false is what it's based on. Quantum computers don't work that way. With quantum computers, it's more, if you understand matrices and finding the optimal solution using pivot points, the way he was describing it reminded me of matrices and pivot points and optimal solutions. You have a set of data, but there's one optimal solution. And with qubits in quantum computing, you have a set of data, and it returns the optimal solution. So that's really interesting, and it does it quickly. So what quantum computing does right now is it performs operations, but they're not as good as traditional computers. And there's a certain number, I don't know if qubit is a term, but there's a certain term that regulates the performance ability of a quantum computer. Maybe it is a qubit, and a qubit has a certain value. Maybe it's based on 8, I don't remember. And let's say a traditional computer is based on megahertz, and the higher the megahertz, the faster it is if it's the same chip design. So with quantum computing, the more of these bits you have, the faster it is. Maybe that's what it is. The more qubits you have, the faster it is. And there comes a point where you have like 10 qubit, 20 qubit, 40 qubit. There comes a point where once you get to that point, it's faster than a traditional computer. And I don't think that they're at that point yet, but they're either approaching it, or they know how to do it, or it's too expensive, or maybe they've tested it, but it's not far. I don't think it's far into the future. So in general, I think the belief is that quantum computers do not compete with traditional computers at this point, but they're doing a really good job, and they're going to in the near future. There's more than one company that manufactures quantum computers such as D-Wave, and Google might have their own. Is there anything else interesting about the Big Bang Theory? Well, at some point you're going to get into evolution. And people ask themselves, well, how did life start? And this is one of the big holes with evolution versus creationism, because nobody can give you a firm answer. But there has to be, I don't know if it's a protein and a peptide or something like that. There has to be two chemicals, one of which I'm pretty sure is a protein, and another that somehow have to form the first cell. So creation is the beginning of the first cell. And they've done tests to try and prove it, and I'm not sure if they've succeeded at it, but they've tried to prove it, and it has to happen on its own in nature. So you have the Earth, a planet, and you have the ground, I'll call it, and the water and the air, etc. And before you have modern life, there was a different form of life that no longer exists, that was gone, because there was no oxygen. And this form of life dominated the Earth. It did not use oxygen. But I believe what happened was oxygen was its byproduct, just like ours is carbon dioxide. And its byproduct was toxic, just like carbon dioxide is to us. But the problem is there was no balance. So it started producing oxygen to the point where it produced so much oxygen that it killed itself. It didn't have enough of the fuel that it needed. It only had the exhaust, as you could say, and they all died off. And then we have the modern life that we know. The oxygen-based life forms started forming. And something that I know from a long time ago is that life is probably going to start in the ocean. And plant life, so single-celled organisms are going to come before everything else, and then you're going to have complex cells, but plants are going to come before animals. And animals in the sea are going to come before animals on land for a variety of reasons. And then you're going to have the animals that can crawl onto the land, and then you're going to have the simple animals that are on the land, and then you're going to have the more complex animals that are on the land. So one thing that you cannot answer based on all of this is, where does the human soul come from? The ability to see, hear, feel, think, etc. Not explained anywhere in science as far as I know. And I studied philosophy. I think before I am, but how do you know how do you think? And I know from computers, I know how logic works. We know the way thinking occurs, and memory, we know how memory works. And we have microphones and speakers, and we know the mechanics of everything. And we know that the soul must be like software. Software is just a bunch of bits on a hard drive that we have a high-level language for, but really it doesn't exist, you could say. But nobody knows. Science does not explain. We explain the existence, perhaps, of a soul, but not the why or the fact that it really happens. So that's the big missing thing from science and the Big Bang Theory and evolution and philosophy that I've never gotten an answer to, and perhaps I never will.